This in-class quiz might become a you take it home and bring it back on Monday. Can you live with that?
Yeah.
No, we can't live with that. No, we can't live with that. No. And then if there are other questions, we can just pick them up on Monday before we we go outside and do the grade calculations I was planning on doing. So we'll get it done. Lights off, okay? You're decent. Tell me your name.
Michelle.
Michelle, go.
Did we already turn in those quiz things?
We did up here, but just on the way out, just drop it on the pile. That's totally fine. So let's grab any one of the equations up there and walk me through the solution to it. Walk me through the solution to it. So you pick, and what I'm going to do is I'm going to have you guys tell me what to do. So in other words, I'm just the scribe that's doing what you tell me to do. And I want you to ask questions as we go, because I don't know, this is all like 60, 65, 95 stuff, but I know you've also forgotten a bunch of that stuff. I get that. I totally get that. So what I want to do is I want to get us all basically on the same footing, and I want this to kind of be that learning process. All right, so pick an equation. Let's pick an equation and solve it. Tell me your name again.
Toby.
Toby, go. Pick an equation. Which one?
The first one.
The top left.
Yeah.
3x plus 5 equals 9.
Yes.
Let's talk about that.
So you're first gonna get, you're gonna subtract 5 on both sides.
Why?
Because
See, I'm lying already. I'm not just being I'm going to ask questions too.
Because you're working towards getting the x by itself.
But why would you subtract 5 first?
Because you're trying to get 5 away from 3x plus 5.
Okay, why not divide by 3 first?
Because then I will have 0 after I subtract 5 with 3x plus 5 and make...
Wait, say that again.
If I subtract 5 on both sides,
Yes.
I'm going to end up with 3x equals something, and then I'm getting rid of the 5.
So one solution, we'll come over here and tell us solution number 1, is subtract 5 from both sides, which gives us 3x left. If you imagine this as a scale, where 3x plus 5 is on one side of the scale, and 9 is on the other, subtracting 5 is like taking 5 whatevers off that side of the scale, but then the scale is going to do this. You've also got to take 5 off the other side to bring it back to balance. So by pulling 5 off of this side and 5 off of this side, it remains balanced, it remains equal. So you end up with 3x on this side and 4 on that side. So we've essentially lifted the same amount of weight off of both sides of the scale. Is that fair? Now what do we have to do?
Now I'm going to divide 3 from both sides.
Why?
Because I want x by itself, and that'll cancel out the 3.
Okay, right now the scale has 3 times as many of the things on this side that you want. You don't want 3 of them, you want 1 of them. So you're going to take away all but 1/3 of them. So you've got to get rid of that 3 via division or multiplication. I don't know what you just said to do.
Right.
Dividing both sides by 3, you get x equals 4/3. And now you've got 1x by itself on this side and 4/3 by itself on this side. Which you can then, if you want, check back in the original to see if it works, right? 4/3 times 3 is 4, plus 5 is 9. What's on your mind? What's on your mind?
To answer your previous question, you can divide by 3 first.
Hold that thought. Give me 30 seconds. I want to make sure. Time it. It's good. When Toby said to subtract 5 first, how many of us in the room said, yeah, I remember that from like Math 60. Yeah, you dump the 5 off first. What did they tell you in Math 60 was the rationale behind that?
Order of operations.
But now here's I love that answer, by the way. Thank you, order of operations. I have a question, a reverse question for that. Order of operations, if I was the value x, so suppose I wanted to check the answer, I want to guess, x equals 7. That's my answer. If I were 7, what would I do to that first by order of operations? I multiply by 3, and then, so whatever, if I'm trying to check a value for x, I would actually, by order of operations, multiply by 3 and then add 5. Multiply by 3 and then add 5. But when you solve an equation, you're not trying to create the expression, you're trying to undo, very good, undo or deconstruct the expression. I used an example back here with, tell me your name. Mariah, thank you. I'm not sure if it's a good, I'm going to try it on you guys. I build Legos with my son very often. And very often I'll build something, in his opinion, wrong, and I have to rebuild it. So let's suppose I take a gear, I stick an axle in the gear, I place that axle through a holy plate, I put a coupling on the holy plate, and then I drop a couple more bricks on top, and then I put the fan on top. And Max goes, Dad, damn it. You put, well, he's 6, doesn't swear yet. Sorry, buddy. You put the wrong size gear at the bottom. I'm like, oh crap. He's like, take the whole thing apart and start again. So remember the order of how I built it? Gear, axle, plate, coupling, brick, fan. What has to happen first if I unbuild it?
off.
The fan has to come off. Followed by brick. Followed by coupling. There's a lot of steps there, I apologize. So when you build something, to deconstruct it, you have to go backwards with opposite operations. Whenever you solve any equation, keep that in mind. If you know how this was built, you know how to unbuild it. Since the last thing you did in building this was adding 5, the first thing in unbuilding it, or undoing it, or deconstructing it is to subtract 5. And then dividing by 3. That's a way to deconstruct it. That's not to say that Randall says we can solve it a different way. We could divide by 3 first. A lot of students, how many of you tried that? It works. You got to be uber careful when you do that. You have to be careful when you do that because the 3 has to also divide into the 5. And since students always forget that, let's just let that one go and work on always trying to undo what has been built. Is that fair? Undo what has been built. Undo what has been built. Fair enough? That'll solve any linear equation for you bomb-proof. Bomb-proof. And I think the reason Math 60 becomes such a hellish experience is because it seems like it's a set of rules, a set of rules, a set of rules. It's one rule. Figure out how that expression got put together and take it apart. It's Legos. It becomes Legos. Yes?
In Math 60, I had an instructor that said on one side put what you do to the equation, and then on the other side do it backwards, and that's how you do it.
Your first project that you're going to turn in 2 weeks has all those. Your first project you're turning in a couple weeks is all about equations kind of like this one that you're undoing with multiple variables in them. And the whole first 2 pages of that project are showing you that. Exactly what your instructor, give your instructor a pat on the back next time you see him. That's exactly what we're describing. You undo what you have done. I don't have enough board to do it here, unfortunately. All right? All right, let's try another one. Let's try another. We'll just call this the solution method. Yeah, grab that if you want to take it. And this is, wait, hang on a second. We had Ryan and we had Chad. Chad, go!
I'll do the last one.
Oh, the last one. We'll go straight to the last one. All right, let's pause and restart. Gesundheit. Actually, you know what, Chad? Not to